Hi, this is Mrs. Rodriguez, your Algebra 1 teacher. This video is a review for the Chapter 5 test that's coming up. So I'm going to go through some questions that are going to be very similar to the ones that are going to be on the test. I recommend what you do is if this is your first time watching this video, these types of videos, I recommend that you, when the problem comes up on the presentation, pause it, try to solve the problem yourself, and then continue to play the video. If your answer is the same, then great, move on to the next problem. If you got a different answer, make sure you pay attention to my explanation and everything, and then hopefully you figure out what your mistake is. If you can't figure out what your mistake is, then either call, text, email, or stop by my office hours, and I'd be happy to help you with that problem. Okay? All right, so let's go ahead and get started. Okay, so like I said, this is for the Chapter 5 test, and this is a practice test that can be found on page 327 of your textbook, okay? All right, so key concepts. First, for lessons 5-1 and 5-2, says for all numbers A, B, and C, the following are true. If A is greater than B and C is positive, then A times C is greater than B times C. And if A is greater than B and C is negative, then A times C is less than B times C. Okay, so basically what you want to remember when you're solving inequalities, one step, two step, multiple step, whatever it is, you solve them just like equations. The only difference is that when you multiply or divide by a negative, you have to flip the direction of the inequality symbol. Okay, so let's look at a few of these. So number one says to solve each inequality and then graph it on a number line. Okay, so first here, this says x minus 9 is less than negative 4. So we do the inverse or the opposite. And instead of subtracting 9, I'm going to add 9 to both sides. So I end up with x is less than 5. Okay, and then when I graph this, the nice thing is when my variables on my left side, this inequality symbol, it's like a little arrow and it's pointing at the direction in which I need to shade. Okay, so it's pointing to the left, so everything to the left is going to be shaded in. I have an open circle at 5 because x is less than 5. It cannot be equal to 5. It can be 4.99999, but it cannot be equal to 5 for this to be true. Okay? All right, let's look at another problem. Oh, now we have multi-step and compound inequalities, and these are lessons 3 and 4. Multi-step inequalities can be solved by undoing the operations in the same way you would solve a multi-step equation. So this is what I was mentioning earlier. And then a compound inequality containing and is only true if both inequalities are true. So if it's and, both of them have to be true. If one of the inequalities is not true, then that would be false and that's no solution, okay? And then a compound inequality containing or is true if at least one of the inequalities is true, okay? At least one. So as long as one of them is true, then it's a true statement, okay? All right, so number 2 says to solve each inequality, then graph it on a number line. Okay, so we have variables on both sides here. So I'm going to first subtract 5p from both sides. So 6p minus 5p, I'm left with 1p, or just p. And then I still have this minus 3 or negative 3. Okay, so then when I graph this, then I'm going to put a circle at negative 3. And it's going to be shaded in because it's greater than or equal to, so it can be equal to negative 3. And then everything to the right is going to be shaded in, okay? Because my arrow is pointing to the right, the variable is right here on the left side, okay? All right, then number 5, another one step here. So I'm going to divide both sides by 7 here, okay? Now 7w divided by 7 is just w. Is less than or equal to. Now I divided by a positive number, so I'm not flipping any inequalities, okay? And then negative 42 divided by 7 is negative 6. So when I graph this, I have a circle at -6. I'm going to shade in that circle because it's less than or equal to, and then my arrow is pointing to the left. Everything less than -6 is going to be shaded in. Everything less than. Okay. All right. And then number 9, here we have a two-step equation. So first, I'm going to subtract 3 from both sides. So I have g over 4, this is gone, less than or equal to, and -9 minus 3. Remember, you add the opposite. So -9 plus -3 is -12. Now I subtracted by 3. I had to multiply or divide, so nothing happens to my inequality here. And then now I have a one-step equation, g divided by 4. So I do the inverse and multiply both sides by 4. And I have g is less than or equal to -48. Again, I don't flip my inequality. Okay, I multiplied by a positive number. And so I have a circle at -48. It's going to be shaded in because it's less than or equal to. It can be equal to -48. And then everything to the left is going to be shaded in because it's less than, and my arrow is pointing to the left. Okay? All right. Number 10. Again, we're going to solve this inequality. So lots of inequalities on this test, okay? So first thing we have to do is distribute. Now, remember, when you are distributing, you have to multiply what's outside the parentheses by both terms inside. I'm still seeing students make mistakes on this, and they're not multiplying the second term, okay? So make sure you don't do that. So -2 times -4 is going to be +8. Negative times negative is positive. Bring everything else down. Now here, I want my variable to stay on the left, so I can do one of two things, okay? I can subtract 5x from both sides, or I could have added 2x to both sides, so we can solve it both ways, and I'll show you the difference, and you can see which way you prefer. So if I subtract 5x here, -2x minus 5x, remember I add the opposite, so that would be -7x plus 8 is greater than or equal to -13. So then I have a two-step equation here. I'm going to subtract 8 from both sides. I end up with -7x is greater than or equal to -21. Now I'm dividing by -7. -7. So I have to flip that inequality. I'm dividing by a negative. Okay? And then this is x. And then negative divided by negative is positive, and this is a +3. So when I graph this, I have a circle at +3 here, and it's going to be closed circle, okay, because it's less than or equal to, and then everything to the left is going to be shaded in, okay? Now, if let's say you wanted to keep the variable positive. So at this point, when you had -2x plus 8 is greater than 5x minus 13, now we could have added 2x here, okay? This would be 8 is greater than 5x plus 2x, that's 7x, and then minus 13. So then I would have added 13 here. So then I have 21 is greater than 7x. I would divide by 7, a +7. So this would be 3 is greater than x. So when I rewrite this with my variable on the left, I flip that inequality. So x is less than or, oh, I'm sorry, this was supposed to be greater than, not greater than or equal to. Okay, I'll fix that. And then x is less than 3. So I have an open circle at 3, and everything to the left is still going to be shaded. Okay, so sorry about that here. So this, oh, it's not going away. Okay, so this was supposed to be oh, okay. not going away. So I'll just cross this out. Okay, so this was supposed to be just greater than, this was supposed to be just greater than, and this was supposed to be just less than. Sorry, I made a mistake there. I just, for some reason, added that, or equal to. So this would have been an open circle, okay? Open circle at 3. So then the graphs are the same. Sorry about that. All right, so next problem, number 11, says the 8th grade science class is going to the zoo. The class can spend up to $300 on admission. And it says for part A to write an inequality for the situation. Okay, so you have to look at the table, and it says for each student, it's $8. So 8 times the number of students plus, it's a field trip, so adults are going to go, and it's $10 for each adult. So $10 times the number of adults, and they can spend up to $300. So the maximum they can spend is $300. So they want to spend less than or equal to 300 because it can be equal to 300. Okay? All right. And then for part B, it says if there are 32 students in the class and 1 adult will attend for every 8 students, can the entire class go to the zoo? All right, so there's 32 students, so I'm going to put 32 in place of S, and then it says there is 1 adult for every 8 students, okay? So there's 32 students, so 32 divided by 8 is equal to 4. So there's 4 adults that have to go on the field trip. So we'll see if we end up with a true statement, okay? So 8 times 32 is going to be 256, and 10 times 4 is 40. And then if we add 256 plus 40, we get 296. And is that less than or equal to 300? Yes, it is. So yes, they can go on the field trip, okay? Because that is a true statement, okay? This is true right here. All right, let's go to next problem. Number 12, it says solve each compound inequality and then graph the solution set. Okay, so this is a compound inequality because it has this or here. So this is like a one-step inequality over here. So I'm going to add 8 to both sides, and I end up with y is less than, and negative 3 plus 8 is going to be positive 5. And then over here, I have y plus 5 is greater than 19. So I'm going to subtract 5 from both sides. So y is greater than 14. So when I graph this, I have an open circle at 5, and everything to the left or less than is going to be shaded in, and then y is also greater than 14. So an open circle and everything to the right is going to be shaded, okay? All right, so in order for this to be true, y either has to be less than 5 or greater than 14. It can't be any numbers in the middle like 6, 6.5, 6.2, things like that, okay? All right, then number 13, here we have another compound inequality. So here I have a 2-step in the middle here in between my 2 inequality symbols. So first I'm going to add 5 to both sides. So that's gone, and I have negative 11 plus 5 is negative 6. It's less than or equal to, I'm left with 2h is less than or equal to 13 plus 5, which is 18. And then I'm going to divide everything by 2, by positive 2. So negative 6 divided by 2 is negative 3, is less than or equal to h, which is less than or equal to 9. So h is less than or equal to 9 and greater than or equal to negative 3. So when I graph this, I have a closed circle at negative 3 and also a closed circle at 9 because they're less than or equal to and greater than or equal to. And everything in between those two numbers is shaded in. Okay? All right. Oh, and then we can write this solution set as h such that it's -3 less than or equal to h less than or equal to 9. Okay? Sorry, I forgot to do that on those other problems, but this is how you will see the answer options on the multiple choice part of the test, okay? All right, so number 17, here it says to write a compound inequality for the graph shown below. Okay, so here it's given you the graph, you have to write the compound inequality, okay? So notice this is going to be an or, okay, because they are split. There's a gap between these two here. So this is saying that x is less than or equal to, because it's shaded in, -2, okay? And so over here, x is greater than or equal to +3, okay? So it can only be h or g, and this says x is less than -2, but our circle is shaded in, so it cannot be h, it has to be here. It says x is less than -2 or x is greater than 3, which is what we have. So it has to be g, okay? All right, so then you had a section on absolute value inequalities. So the absolute value of any number, x, is its distance from 0 on a number line, and it is written as the absolute value of x. If x is greater than 0, then the absolute value of x is equal to x, meaning it's going to be positive. If x is less than 0, then the absolute value of x is equal to -x, okay? So, because remember, when you take the absolute value of something, it's always going to be positive. So what's inside the absolute value symbols could be positive or negative, okay? So we have to solve for both of those cases, okay? So if the absolute value of x is less than n and n is greater than 0, then -n is less than x, which is less than +n, okay? All right, so let's go ahead and try a couple of these. So here it says to solve each inequality, then graph the solution set. Now here, there's nothing around the absolute value symbols, okay? So I can go ahead and split this off into the two cases. If there was like a +5 or something, I would need to subtract that 5 first. Whatever is outside the absolute value symbols, you get rid of it first before you split it into your two cases, okay? All right, but there was nothing around these absolute value symbols, so I'm going to split it into my two cases. So p is less than 5 is, p minus 5 is less than 3, or p minus 5 is greater than -3, okay? So then I'm going to solve both of these inequalities. So I'm going to add 5 to both sides, so I have p is less than 8. And then over here, I'm going to add 5 to both sides, and p is greater than +2. So now, when I graph this, I have an open circle at 8, okay? And then I have an open circle at 2, and then everything in between is going to be shaded because it's greater than 2, but less than 8. So the only way this inequality is true is if the value is greater than 2, not equal to 2, okay, but greater than 2, but less than 8, okay? All right, and you would write that as 2 is less than p, which is less than 8, okay? All right. So here's another one. Now here, this is like a couple of two-step inequality, absolute value inequality here. Now again, there's nothing around my absolute value symbols, so I'm going to split it off into my two inequalities, case 1. And over here, I'll do case 2. And I'm going to switch my direction of my inequality, and then this 15 is -15, okay? So then I'm going to solve this, subtract 3 from both sides, and negative 4m is less than or equal to 15 minus 3, which is 12. And then I'm going to divide both sides by negative 4. So I'm going to flip that inequality, and 12 divided by negative 4 is negative 3. Then over here, I'm going to add 3 to both sides. You get negative 4m. It's greater than or equal to negative 15 plus 3. It's negative 12. Okay, now again, I'm going to divide by negative 4. So I'm going to flip my inequality symbol. And then, oops, I was supposed to subtract 3 here. So this is a minus 3. So this should be a negative 18 here. Sorry about that. So I was supposed to subtract 3 from both sides. That just changes this negative 8 to negative 18. So negative 18 divided by negative 4 is going to give me positive 9 over 2. Okay. So then when my solution is going to be negative 3 is less than or equal to m, which is less than or equal to 9 over 2. So when I graph this, I have a circle at 9 over 2, and it's going to be closed because it's less than or equal to. And then at negative 3, it's going to be greater than or equal to negative 3. So it's a closed circle. It's greater than. So everything in between here is a solution to this inequality. Okay? All right. So next problem, word problem number 22. It says a sporting goods store is offering a $15 coupon on any pair of shoes. The most and least expensive pairs of shoes are $149.95 and $24.95. What is the range of costs for customers with coupons? Okay, so now you might look at this and say, okay, well, the range, the cheapest one is $24.95, and then the most expensive one is $149.95, but it's asking what is the range for the customers with coupons. And remember, the coupon is a $15 coupon. So we are subtracting 15 from each of these values here. Okay, so this ends up being $9.95, and then this ends up being $134.95. So if you have that coupon, the shoes will be between $9.95 and $134.95. So quite a big range there. Okay. All right. So then inequalities in two variables. Okay. So this is where you had to graph inequalities. Okay. So first you have to graph the boundary line. So use a solid line when the inequality contains less than or equal to or greater than or equal to, because it can equal those values. And then you use a dashed line when the inequality contains less than or greater than. And you can use a test point to determine which half plane should be shaded, and then you shade the half plane. Okay? All right, so first thing you have to do is make sure it's in slope-intercept form. That's the easiest way to graph it. Okay, so we want to get y all by itself, so we try to isolate y. So first thing, I need to get rid of that 2x, so I'm going to subtract it from both sides. So I have 3y is greater than or equal to negative 2x plus 12. Then I'm going to divide both sides by 3. So I have y is greater than or equal to, again, I'm not flipping my inequality because I'm dividing by a positive. So I have negative 2 divided by 3. So I'm going to leave that as negative 2/3 x, and then 12 divided by 3 is positive 4. So my y-intercept is equal to 4, and my slope is equal to negative 2/3. So when I graph this on my y-intercept, I have a point at positive 4, and then my slope is 2/3. So I'm going to go down 2 and to the right 3, and there's another point. I could do it again, down 2 and to the right 3, or I can even go up 2 and to the left 3. Now, this is greater than or equal to, so this is going to be a solid line, okay? Now, we need to decide, am I going to shade above or below? Now, it's greater than or equal to, so everything above should be shaded, okay? But you could pick a point to test out. Let's pick this point here is 4, 3. Okay, so I'm going to test 0.43. The way I do that is into the original inequality, I'm going to plug in 4 for x and then 3 for y and see if I get a true statement. So 2 times 4 is 8, 3 times 3 is 9, and if I add 8 and 9, that's 17. And is 17 greater than or equal to 12? Yes, it is. If I test one of these points, let's try, keep positive here. Let's test point 1, 1, okay? So again, put in 1 for x, and also y is also 1, greater than or equal to 12, and see if it's true. So 2 times 1 is 2, 3 times 1 is 3. When I add 2 and 3, that's 5. Is 5 greater than or equal to 12? No, it's not. So I know I shaded it correctly. It's everything above the line. Okay? All right. So here, number 25 says to graph y is greater than negative 2x plus 5, then determine which of the ordered pairs in here are in the solution set. Okay? So first, I'm going to graph this. It's already in slope-intercept form, which is nice. So my y-intercept is 5, and my slope is negative 2, which is the same as negative 2 over 1. Remember, I want the rise and the run. So I can either go down 2 and to the right 1, or up 2 and to the left 1. Okay? So this line is going to be dashed because it's greater than. Okay? So when I graph this, it's going to look like this. Okay? And everything greater than is going to be shaded. So everything above this line. Okay? So when I test these points, I can do one of two things. Well, I already graphed it, so I can plot these points. So negative 2, 0 is over here. Negative 2, up 0. So this point is not one of the solutions. Okay? Negative 1, positive 5 would be up here. This point is also not one of the solutions. 2, 3 over 2, up 3. This one is above the line, so this is a solution. And then 7, 3 is also a solution. So which ones are solutions? 2, 3, and 7, 3. The other thing I could do is plug in these values. Let's say you didn't graph it and it's just asking, is this point a solution to this inequality? You plug in the x value, you plug in the y value. If you get a true statement, then yes, that point is on the graph. If you get a false statement, then it's not. So let's test just a couple of these. So let's say it was, let's do negative 2, 0. So we plug in 0 for y is greater than negative 2, and for x, we're going to put in negative 2 plus 5. Remember, I'm just plugging this into the original inequality. So I end up with negative 2 times negative 2, that's positive 4. And 4 plus 5 is 9. Is 0 greater than 9? No. Okay, it is not. So that is not on the graph. And let's just try one that we know is. We'll try 7, 3. So I put in 7 in for y. Greater than negative 2, and in place of x, I put no, this is 3 is greater than negative 2, and then x is 7. Sorry about that. And then plus 5. Okay, so this is 3 is greater, and then we have negative 2 times 7 is negative 14 plus 5. So negative 14 plus 5 is negative 9. Is 3 greater than negative 9? Why, yes, it is. Okay. All right. So that would be a solution to this inequality. Okay. All right. And we have a word problem here, number 26. It says Mrs. Jones is buying new books and puzzles for her preschool classroom. Each book costs $6 and each puzzle costs $4. Write and graph an inequality to determine how many books and puzzles she can buy for $96. Okay, so each book is $6. So 6 times the number of books plus each puzzle is $4. So 4 times the number of puzzles. And it's going to be less than or equal to 96, okay? Now we want x and y because we're going to graph this. So this is 6x plus 4y is less than or equal to 96. Now, to graph this, I need to get this in slope-intercept form. So I'm going to subtract 6 from both sides. I end up with 4y is less than or equal to negative 6x plus 96, divide both sides by 4. So y is less than or equal to negative 6 over 4, which is negative 3 over 2x, and then 96 divided by 4 is 24. So when I graph this, so these are all positive values. This is my x, this is my y, and I have the y-intercept is at 24. So let's say this is 24, so I'm going to go by 6's here. So it crosses at 24. And then my slope is going to be negative 3 over 2, so down 3. Let's say each of these are 2, like this. So down 3 over 2, 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 and then down 3 over 2. Okay? And then this is going to be a solid line because it's less than or equal to. And then everything below is going to be shaded in. Okay? So anything above the line would be over $96, which is what you wanted to spend. Okay, so any one of these points is a possible solution or a possible combination of pen puzzles and books. Okay, all right. And that's all. So if you have any questions after going through this video and trying these problems, you can call, text, email me, or stop by my office hours, and I will be happy to help. And you have a great day.